All right, good afternoon, everyone. I hope everyone is doing well. Thank you all for joining us today. All right, let's get going. Things are moving very fast in the AI space. We are actually a data science community, and AI is part of it. But um, the speed at which things have been moving, it's literally impossible to keep up, even for sometimes the AI to keep up. Anyway, we'll talk about how things are moving, where there are opportunities. The community focus is in trying to see how we can engage, learn from each other, and see where the potential opportunities, what is happening, what's growing, where are the trends. So that way we keep ourselves on top of the curve and hopefully help each other out getting better. So in that spirit, let's just talk about what we are. We are a community which has been around for over 10 years now, over 100 meetups that we have had so far. And over the 10 years, we have progressed pretty well. We may have missed a few meetups, but we meet or we try to meet every month. And the cadence is usually the third Saturday of the month. We will be having a few adjustments as we are going forward. We do have connections on LinkedIn, um, and anybody who's been receiving my emails also knows how to reach out to me via email. And some of you also have my phone numbers. So in case you need to reach out, please feel free to anytime. We are here to help each other out. So the agenda for today is just a quick 10-minute on, how things are moving. And it's a whole team of us back here who are building this, and a great contribution we have from Aparna most of the months as to keeping us up to pace on how things are moving in the industry. Then we will be talking about a data engineering. So as with data science and as with AI, your intelligence or intellect will be present, but your wisdom is only as good as the data or the intellect or intelligence that you have gathered in terms of data and the quality of that data and the relevance of that data. So, data continues to be the strong pillar on which any structure that can be built, uh, you know, happens to back on or rely on. So, those pillars have to be very strong for the AI building to be strong. Then we'll have a short break and we'll connect back where Pratik, who's in the room today, is going to talk about the classical data science learning, unsupervised learning as to how we take images and try to figure out what's going on in the brain. Because no matter how well AI does or how good we do, nothing is going to beat the brain for a fairly long time to come. So that's the agenda for today. Moving on to the meetings. The next one is scheduled for September 19th, and we'll be talking a little bit about LLMs and there's going to be some conversations more on the AI space in the next month. October, we are moving it 1 week ahead because of the availability in the library. So we are meeting on October 10th. And November, again, we are kind of moving it 1 week ahead just to skip all the stuff going around on the Thanksgiving time. And December, we'll be meeting on the 19th. So that's our meeting schedule as of now. Unless anything dramatic happens, we will be sticking to those dates. So I look forward to seeing you guys and others who you can spread your word around with. You know, it's a great place to be learning. Okay. So getting on to what's been happening in August, Google, which is kind of starting to catch up a bit on on this space. We have new models coming out, and there is more focus on the agent workflows in that space. A little more of the agentic is going enterprise, not just a buzzword anymore. Safety and governance. I think we have been talking about it for a few meetups already. this is going to be a space where there will be opportunities. And there will be opportunities because, um, you know, way back in the 80s, IBM used to say that, you cannot trust a computer for any management decision. So essentially, governance has to step in to ensure that there are those boundaries, there are those guardrails. I think guardrails is probably the word that gets hyped about a lot. Just to make sure that things are done in a proper way and not causing unnecessary expenses, not causing unnecessary areas of friction, and ensuring that all the data regulations that are in place are maintained and the policies of the different companies are being adhered to and the model doesn't just take over. Google and Anthropic are on the rising trend. OpenAI had its own bumps the last month. And then basically about data engineering, some of the areas that we can kind of focus on a little bit is learning. So this particular section here onwards is talking a little bit about AI and where you can get your learning material from. So this is a small collection of resources. I would strongly encourage you screenshot this or you take a picture. I haven't seen much of sharing happening on the PDFs that we end up sending. I don't see a lot of people downloading that. So please do screenshot this or make notes whatever way you have best way of capturing this information. So every month we do share links that'll be useful for you so you can go back and spend some time on those. Um, it's this is something that we're going to repeat every meetup. It's becoming agentic. It's not just about language, it's about how do we take it and use it and apply the language or the intelligence that or the wisdom or whatever strategies that we can develop using LLMs into work activities. It's getting cheaper and you know if you've not been in the space of technology, you have missed out the fact that AI is taking over a lot of the coding. So that's a basic trend that's happening. So a lot of tasks are going to the on the coding side are going to the AI models, and at this time they seem to be doing a fairly decent job of it. Of course, they still don't have the awareness of the domain, so there will always be the need for people to take the raw code and then fit it into a polished outcome. Governance skills are pretty much essential. If you don't have a profile which shows you've been doing courses and being on AI, you're being, overlooked in many cases. And that's pretty much as far as takeaways are concerned. There are a lot more data ready platforms coming up. Real-time data is becoming more and more into the picture. In 2023, when OpenAI came out, they were 4 years behind or 3 years behind with a lot of the scraping that they had done. But right now, it's like real time. A lot of the intelligence or LLM building is also doing real time. Simple models, RAG, we've discussed that a few times in the last few meetups. And the fact that just like when there was explosion of the cloud, another area where you'll find opportunities is how do you optimize the cost? So when cloud initially came, people were spending a lot, and then there were people who would come in and charge money just to reduce that spend. So platform optimization is going to be happening in this space as well. Spend can be easy. Um, More about data engineering technologies on this particular slide. Again, I'll just briefly go over. There's not much that's not discussed in the previous meetups already, but you know, the third button here, the third bullet here, the data quality and observability. That's a space which is still, I think, underserved right now. Maybe even underfunded at this point, but there is potential for that. That one and the fourth one, the metadata lineage, especially when you're building your data pipelines, that space is has got potential, and that's what Aparna is going to be talking about, leveraging some tools to make it better. All right. And I'll just skip over this particular slide and move over to the next section, which is basically talking about pipelines. Um, this is one company's take on it. So Aparna will be talking about this. So whenever you're ready, Aparna, if you can start sharing your screen, I'll stop my share.
Yeah, so as Suresh mentioned earlier, right, we are talking about AI, but also the foundation pipeline for AI is the data, right? So that's why data engineering becomes really important in providing that data for further insights and when AI can take over. Now, when we talk about data engineering and AI, right, there's a combination that is available in tools these days. And this presentation is basically, I'll demonstrate how a data engineer can use Genie code in Databricks. Databricks is one of the data engineering platform, or either I would say it's an ecosystem, not only for data engineering, but also MI, etc., ML, etc. So basically, this will use Genie code in Databricks to accelerate the development of a production-oriented data pipeline. We'll start with Unity Catalog. Now, Unity Catalog in Databricks means it's kind of a placeholder for all the files, and not only for the files, also for the data governance and the permissions, etc. But just for a start, Unity Catalog, you can think of it as a folder for all your source data. Now we are going to work with three source tables to keep it very simple, right? We'll take retail pipeline, which means we'll use orders, customers, and products just to demonstrate how this pipeline is built in sync with the Genie code, that is a AI perspective. Now, the goal here is not simply to generate code, right? Definitely, there are a lot of tools to do that. But a production data pipeline also needs data quality, incremental processing, security, observability, testing, deployment, and operation controls. So Genie code can accelerate many of these activities, and of course, with the engineer being responsible while that is happening also. So we're also talking about human you know, um, in the picture, so that everything is kind of looked at from a production readiness perspective. So the Genie code acts as a data engineer assistant inside Databricks, and I'll go through demo. So just for discussion sake, you can think of it as like a code generation or some kind of an engine sitting within the Databricks. It can use available workspaces, etc., and it'll make more sense when I do the demo. But just for the perspective for understanding here, you can think of it as something that sits within the Databricks environment to make developers' life much more easy. So basically, I'm not sure if all of you have this medallion architectural kind of a pipeline. And what this says is you have source systems. So that is your source for the start of the data pipeline. And the next stop is having like a landing zone. And here the landing zone is termed as a bronze layer. So in order to relieve the source systems, this layer will kind of be a landing zone for building your data pipeline. And so no checks here, no validations, it's just a landing zone as the name says. And the next is the silver layer, which will actually cleanse the data, dedupe, do a join, do validations, all kind of transformations you would need for a typical data engineering pipeline. And then the final layer will be the gold layer, which will aggregate data and make it business ready. Basically, it will be in terms of materialized views. So this entire layer structure that I'm talking about here is actually called medallion architecture, which is now supposed to be the most sort out after kind of a architecture. So generally we talk about prompt engineering also here, right? So in this case, what we are going to do is, and we'll make it more evident in the demo, but you give a prompt here saying that and in this case, we are giving data by we are going to make it imperfect just for it to understand the data quality issues, etc. So we're going to make duplicate orders. We're going to have invalid records so that we can figure out how the quality will actually quarantine the invalid records, etc. in the data pipeline. For you to understand that what are the capabilities of increasing the data quality, etc. So here we are going to actually tell the Genie code to give a plan, and then once you review the plan, we will tell it to generate implement the code. So this is something that it will create by itself. And this will all make sense when we go through the demo. I'm just trying to go through this in advance just for you to get a feel of what it will look like. So generally, when this code is implemented, we would look at it from a data correction perspective. We'll try to see, what are the performances that can be, what are performance tweaks we can do to it. Is there any cost, increase by the way we implement and things like that. So there will be a engineer who will actually own this pipeline as well. So we're not making it totally onto the AI part for making the decisions. So in also the case of data quality, right, there is something called expectations. What expectations does is basically making a data rule from a business aspect. For example, if your order ID is null, right, those kind of things that you would know from a business as to if you want to drop it or give a warning, etc. So those will be implemented as part of the data quality framework. And in this case, we are trying to create a agentic kind of an approach where you are going to tell the AI part of it in case there is a failure, right, in your pipeline. It is smart enough to figure out what the failure is. It'll give you the diagnosis of the failure and it'll also suggest the corrections. And if you give permissions, it'll go ahead and put in the corrections as well. So that's very interesting as to, I was actually developing I was working on a project and I did have this issue of a failure, right? So instead of going and doing a Google kind of, approach for troubleshooting. We have this within the Databricks environment itself, where I said, okay, this is the issue I'm having. Can you go fix it? So it would make the change. It'll ask if, you're okay to make the change and it'll even run the code for you. So that is something that we're trying to see that it's not only generating the code, it's also troubleshooting and helping you fix the issue on a product aspect. So basically, each layer you're going to step in to figure out if the code is, doing the purpose you wanted it to do. And also at the end, right, you're going to ask if it's production ready. Production ready in the sense that is there any performance tweaks? Is there any permission things that you need to you need to handle, or even the CI/CD aspect of it, right? For a higher environment move, to move, they talk of it as bundles. Bundles is moving of code from one environment to another. And also any kind of a backfill in case there are quarantine records, if you want to backfill into the next run, how you would do it. So things like that are actually making sure that the code is production ready. So typically, this is what I was talking about, the CI/CD, right? So if I'm not sure if everybody's aware of it, but it's like continuous integration and continuous deployment workflow, which is how we've done it earlier in my project. Is we used to have like a Git connection, wherein it was done through Jenkins, where it's used, you have like a unit test, etc. And once that is cleared, it would pass that bundle into the higher environment and something in a very automated fashion. But of course, we used to have like a manual review as well, just to make sure that a human also is in the loop. So I'm going to stop here and do a quick demo. But before we go for demo, are there any questions? I'm not able to see a chat, but let me know if there are any questions so I can answer before I go to the demo. So I will then go ahead to the demo. So this is something that you can try on your own as well, because you can look for a free community edition Databricks, and you get you can subscribe for that. It's a free trial version, and I'll also send code prompts that I'm using here to Suresh. So if anybody's interested, you can take it from him as well. So what I'm going to do, like I said, right, we're going to play with three tables on a retail aspect. I'm just going to show that to you. So this is the Unity catalog I was talking about. So it's basically, I have created three tables, and that is orders, customers, and products. So just to give you a sample view of the data, like I said, we made sure that it is imperfect. So we have duplicate orders. One second. Okay. So let's put in data in those tables, right? So I have queries ready with me. So let me just go and execute that. So what we're doing is we are creating or replacing a table here, and we are also inserting data. It's a little slow, so bear with me. So like I said, what I'm doing here is I'm just creating a table and inserting data, and the similar for the customer and the products query. Okay, so the number of rows inserted were 6. Let's now look at the customer. We're going to do the same for customer, and then we'll look at the data once these are ready. Okay. So now that the data is in here, let's look at the sample data. And like I said, you can try all what I'm doing. I can even give you the queries that I executed if you want to try the same to play around with it. So like I mentioned here, we purposely gave imperfect data. So if you see the order here, we have given two same order numbers. So functionally, that's an imperfection. And also the null, sorry, customer IDs. And also there is a null one here. The order numbers here is the duplicate one I was talking about, and this is the null customer ID. So similarly, if you look at data from a customer's aspect, there's the details about those customers. And the third table is products, where you had product description, the IDs and the description. So it's very basic data. Okay. But just we want to keep it very simple, because the purpose is to understand about the Gini code. And the Gini code that I was talking about is, if you see the icon here, this is the Gini code. So let's open that up. And now we'll try to now that we have created those three tables, we'll try to play around with those three tables to create a pipeline. Now in Databricks, before we go to the demo, I wanted to let you know that it has something called a lake flow declarative pipeline, which is kind of building in a pipeline with the data quality also embedded within that pipeline, with the data pipeline. Pipeline is connecting to the source, getting the data in, doing the transformations, adding the data quality rule, and then you have you can execute the entire pipeline and end to, it's like a workflow, and it will execute end to end data, the pipeline for you. Okay, so let's open. This is the prompts that I was talking about. So the first thing we are going to do is we're going to ask the Genie code not to write the code immediately, but to actually look at the data and understand what the tables, etc. And then it'll tell not to modify any of the data sets. So basically, it's just trying to get the Genie code familiar with the data set. So this is a prompt I'm going to give. Okay, so let's see what it comes up with. It's supposed to be thinking. Um, I know this is too much information for you to go through in detail, but like I said, please feel free to try it on your own. Then you can actually look at it in more detail. But basically, what it's doing, it's looking at the tables, trying to understand the columns in each table, trying to create its business keys, and then it's going to actually look at the potential data quality issues, and it'll give you the total number of specific risk it's doing at the data level. So it's also come up with a join strategy and the incremental processing suitability for the orders, because definitely you will get incremental orders as well. So it's defined that it's going to create a streaming table, which is a Databricks concept. And it's actually giving you a summary of the table information. It's saying it is suitable for medallion architecture, which we just spoke about earlier. And it is telling it's a strong candidate for streaming incremental processing. So basically, it has just reviewed the data and it's giving it suggestions. So that is the first part of it. That is explore the data. Now let's see what we can ask next is we'll tell it to create the architecture and the plan. So make a note here that we're not telling it to execute. It is we're just telling it to tell us what the architecture will look like and what would be the plan for that. Okay, so let's copy this prompt. And like here, it says do not execute anything as yet. Let's put that in. It's actually, again, thinking, and it's going to come up with an architecture plan, but not implemented as yet. I know it's going to be difficult to look at it in detail, but see, this is the architectural diagram it's giving. It's going to look at all the dependencies, the aggregations, the data quality rules, and then it's coming up with the code. It is not implemented yet, but it is coming up with a tentative code for all the layers that we are talking about. And it is coming up with some assumptions as well, right? Because it doesn't have all the business requirements. So it's just trying to figure out what it is looking just by the data and the structures of the tables. So it's asking if you're ready for proceeding with the implementation. So let's see what our next prompt is. So the next prompt is actually to generate the pipeline, right? So I'm going to go ahead and say the architecture looks good. Let's go ahead and make the changes with the logic and the data available. So it's actually going to create those tables. It'll create the pipeline. And then I'll show you how the pipeline looks once it comes up with the code. So before running the pipeline, right, you want to look at you want to say if it is pass or has any other additions to be done before we actually implementing the pipeline. So basically, we are giving it some business rules here to cross check. Because like I said, it wouldn't know your business aspect of it. So that is what you want to make sure, that it passes everything, and then it makes sure that everything is in a pass, or if it needs review, is it a valid one or something that you can bypass? And that's where it's human in the loop. So I'm waiting to look at the summary where it'll actually tell you if it's a pass, needs review, etc. So let's look at each one of them. So the deduplication, right? Remember we had given duplicate order ID, so it's saying it's critical. Are any nulls there? Needs review. Because sometimes it depends on the business rule, right? So that's why it's saying needs review. And if any amounts less than zero are handled correctly, it's passed, but because we have handled it as part of the data quality rule. So it is given the list of critical fixes that you have to do in your pipeline, right? So they're saying that must fix before the deployment. So let's So this is a stage where you will actually, make sure that you're looking at all those suggestions and what are actually critical for you or something that you can pass. So we are telling that these are the rules that we absolutely want, and then we are telling you to show the proposed changes before applying them. So that's why we have kept all these prompts ready. So it's easy to go step by step and make sure that there is a sequential process even for the Genie code. So like we said here, it's not only about generating the code, it's also about looking at the rules, looking at the permissions aspect of it. And later on, we'll also see if it can come up with any production ready items as well. So it's looking at all those rules that we gave, and it is coming up with the code for that. Okay. So we're saying now execute the pipeline and then give the summary counts, which match with the business requirements. So because we had all this in a sequential order, it's easy to just go back and forth with the Genie code. But if not, you can also look at the output that it is producing and then come up with the next step as well. But since you have the entire business logic and the pipeline in your mind, you would want to kind of chart it out so that it becomes easy when you're doing back and forth with the Genie code. So it's going through and it's applying the fixes. Let me go ahead and open the pipeline as it is doing. It is creating this pipeline. So it is telling if it can open. So it is opening up the code that it has generated. I think there is some connection issues. So it's coming up with its own troubleshooting issues. There was some permission issues, so it has gone and fixed that. Bear with me till it finishes that. So there is some issue with the connections. Oh, let me give 1 second. There is some error with that, so I'm just trying to troubleshoot that. We'll ask its help. It's saying it's not available, so let's again run the prompt for reloading it. I think there was some connection issue, and that's why it lost that command. So I'm just going to ask him to reload it. You know what I'm going to do? I'm going to reload my Databricks. I'm just going to stop for a few minutes while I reload. But while I do that, is there any question I can answer while I do that?
I don't see anything in the chat yet.
Okay.
Anything in the room?
Give me 1 second while I read.
Okay. What is the model used for this particular pipeline? And I think you are setting a lot of prompts. Is it you have a choice submodel or they already predefined model?
Yeah, it's a predefined model.
So the pipeline, is it ultimately is your backend databases? Is it something we decide, or it's also part of the company, whatever they provide?
Yeah. So the basic one is provided by the company, but you have a flexibility of updating that. So it will create a kind of a template for you, and you have a capability of updating based on your requirements. It will just give you the skeleton code, and then you can play around with it.
Okay, so the backend can be anything like SQL, Oracle, any cloud implementation. It could be Azure, it could be AWS, anything like that, or how is that?
Yeah, the free Databricks ones comes with AWS, but it's
Okay.
also available on Azure.
Okay. The last question. I saw
Uh-huh.
PySpark in there. So is
Yes.
that so it is running on the PySpark?
Yeah, so Databricks uses PySpark because of this distribution processing, and that's why it's way faster. So definitely, yeah, that is the behind the scene. It used to be Scala. You have actually versions you can use. You can use Scala, you can use Python. Of course, SQL is there, but basically, PySpark is supposed to be the distributed one, so they kind of tell to use that.
Okay, thank you.
No problem. Okay, so since I'm redoing it, it's going to take me 2 more minutes. So any other questions while we wait for that?
Yeah, we have one
Ye-
more question.
Sure.
Is this Genie code only available from the Databricks UI, like you got a login, or is it also available outside of it?
Yeah, this is basically to assist coding within Databricks. So this particular thing is within the Databricks. Yeah. Because basically it's creating a pipeline within the Databricks using that code set.
Hey, Aparna. Since
Yeah.
you're playing with the demo data, right? So it's
Uh-huh.
hardly about few lines of records.
Mhm.
What if I have millions of records for the prompts which we have provided with lot of information, the rules, business logics, and all.
Mhm.
So the processing time, the compute power. So
Mhm.
how the compute power will be handled in the Databricks? For example, if I have a 3 millions of record with various business logics
Mhm.
behind it.
Right.
Anyway, it's my responsibility to design the prompt, but
Correct.
how the
Correct.
computing power is being used? Yeah.
Yeah, it's a good question. So basically, when we are actually doing the coding, right? For your example, if it's 1 million code and you see that the prompt is taking time, right? So you would also suggest that within the code, can you put some performance increase, performance tips that can make it run faster. So the Genie code will also try to put in, those kind of aspects. You can say, can you partition the data? So you will use all the PySpark performance attributes to and give those hints to the Genie code to make it more performance effective.
Okay.
But to your question, I've not tried beyond 1 million, records. So basically, when we do like a POC, and I'm just saying, it's not probably the right way, but when we're doing a POC, we do with a limited set of records, get that skeleton template in, and then play within that template code to kind of further enhance.
Okay. Yeah. Because my question is around the production like records. So
Correct,
I'll be
correct,
talking
correct,
about 3 million or 5 million records. And I
correct,
have
correct.
one more question around the prompts, right?
Sure.
The regarding the genie's behavior. For
Mhm.
example, I wanted to work on like 50K types of records, and I have
Mhm.
a prompt.
Mhm.
And the same prompt if the other engineer has been using it.
Mhm.
So the response of the genie is going to be a deterministic, or it's going to be how the genie is going to be respond. Is it going to get the same results for the both engineers who use the same prompt, or it is going to be a different responses?
Yeah, so it's a good question. And I had the same curiosity, right? So I tried twice using the same data set and the same prompts, and I got exactly the same thing.
Okay,
Uh,
so then it's just a deterministic then. Yeah.
yeah, but I'm not sure. Like, because I tried with a limited set, I can say that it is exactly the same. But if it is, different data sets and, different timings, if it's going to be different, I'm not sure. But for the basic ones, it did give me the same.
Yeah, and one more question on the compute power and the resource usage, right?
Uh-huh.
During the transition, for example, for the same large number of records, during the transaction, like how you saw the pipeline has been broken. So
Mhm.
is there any resume capability, like wherever it is broken, it's going to continue it, or
Yes. Yes. So what happens is, right, in the Genie code, if it's an error, it has broken up, right? And then you tell it, okay, continue from where you failed and diagnose it and fix it. So it'll automatically resume, fix it, and then continue from where it left off.
okay, Aparna, thank you.
Yeah, no problem. Okay, so we got it to run. I'm going to share my screen again. Any other questions? Yeah, there's some interesting questions. So always, sometimes, you don't think in that perspective. So any other questions are most welcome. If not, we'll continue with our. Okay, looks like we're okay. I'm going to go and share again. Okay, so there was some error, so we fixed that. So this is what it had created, right? And like I said, it has created a skeleton code. So this is a pipeline it has created. So what you can do is, and that's what I have done, right? Instead of doing from scratch, I had it create the template for me. There's some failures and it's working on how to fix it. But basically, whatever the code it has, you can pick up, if I say edit. I'm going to use what it has created for me instead of going in scratch, and then I'll edit the code myself, right? So this way, you have a flexibility of changing the code and not totally depending on the Genie code. So that is something that I felt it really useful, even from an app's perspective, right? There is a flexibility in Databricks where it'll give you a template code for an app, and then you go within the app and make the change of whatever. So this is the code I'm talking about. See, it has created, there's some failures and that's why you see red, but it has gone ahead and created all that you told it to do, right? The medallion architecture, it has done the silver, gold, etc. And you can execute the pipeline. There's some errors and that's why it has, not done it. But you can actually go ahead and just tell it to rerun the pipeline. If you want, you can go ahead and, open this and then make the changes as you look at the code. So at least you have like a template to start off with, which is definitely much better than, starting off with a clean slate. So this is something that has been very useful from a data engineering perspective. And then if you see some errors here, right, I can also say, okay, there are some errors here, go fix it. And then it'll try to look at the logs and it'll come up with suggestions and then it'll ask if, it's okay to go and fix it. So those kind of things also are possible. And in the end, you can ask, is this production ready? So it will tell you what are the critical tasks that you need to complete, and what are must-haves as well as need review kind of a aspect. So basically, just wanted to give this flavor of Genie code where you can play around within the Databricks environment to create this pipeline, and then just play around with, do some POCs, etc. It's really fun. You get really addicted once you start on it because of the with the amount of code flexibility you get. And not only from a code flexibility, right? Like you saw how it is telling you with the architecture, with the changes that you need to do. So at least you have like a second set of eyes that are going to look at it. And then, of course, you're the master for your business rules, so you can, implement using that. So basically, this was just like a demo. So I will share whatever the prompts, etc. I was showing with all of you, and yeah, please feel free to play around and get a little more hands-on, because the even though you've seen it, it really helps when you do it on your own. So yeah, that's pretty much it from my side. Any additional questions?
Question from online. Am I audible?
Yes.
Excellent. Great presentation. Question for you. You make it very enticing. It is very interesting, but then I'm concerned about the long-term costs of going into production with after you've created the pipeline and everything is working correctly. Are you charged now for tokens after this pipeline is created and the code is trouble-free and doesn't need to be changed? What happens next?
So it's basically your production ready code, right? So if you've built in proper data quality rules, it's going to be an automation pipeline that is going to execute with whatever rules you've built in, until the next day you see some records that come with a total different new use case of data quality that you've not plugged in.
Parna, assuming it's correct now, let's say you were showing us like 4 or 5 records, but I want to process hourly like 50,000 records. So how do I pay for that? How much am I charged per record, by hour, by megabyte? How do I pay?
Yeah, so there are different compute resources that are available in Databricks, and the cost will be more on those aspects as what you have chosen from a compute perspective. So there are different buckets that are used for charging. So based on what you've chosen for your kind of data for your organization, it'll all be based on that.
Great. So just to confirm then, I don't get charged for tokens for processing records on a pipeline that's already been set up. Is that true?
No, definitely there'll be a charge, but for Genie code aspect of it, I'll have to go back and get that answer for you.
Okay, I'm very now confused. There's going to be a token charge if, in other words, AI tokens are going to be consumed while it's running code. I'm confused why that would happen.
No, that's why I knew I would need to go back and confirm on that part. So I didn't want to give any wrong information for that, for the Genie code aspect for it, but I can definitely go back and get you that information.
I see. And then where do I find this wonderful document you keep mentioning? Because I would love to go through it. You were very expert at it, and I am not. So I'll have to go step by step. And where do I find the document?
Yeah, so I will send it over to Suresh, and he'll probably be able to share it with all of you.
Okay, thank you.
Okay, no problem.
Hi, Aparna.
Hi.
The question, the Gini code is only at the time of development, right? Once the development have been completed, you would be deploying this into some environment, which could be backed by some cloud provider, AWS or Google, right? From that, the Genie won't be in action. The actual code will get deployed. This is continuation of the last question, right? So Genie code is only for development purpose. Is that correct?
Correct. And to figure out if it's a production ready also, you will get those kind of recommendations and suggestions as well before you deploy. But yeah, to your question, once it is deployed, it's pretty much, like I said, if there is another data set that comes in and you need that troubleshooting aspect, probably you will use it. But again, you will get into the development phase of it, right? And the analysis phase of it. But once it is completed, it's pretty much, to the production pipeline.
For the same set of table, assuming the data flows on a daily basis or on some interval, weekly or monthly, right?
Right.
We don't need to do development. The new data gets onboarded,
correct,
right, periodically.
Correct.
Right?
Correct.
That time we don't need this Genie. Only the
Correct.
pipeline have been deployed into production, right?
Correct.
The whatever you have orchestrated is for only for the development phase.
Yes.
Is that correct understanding?
That is right.
So the token usage, the question before came out, the token usage is only at the time of development, not at the in the production run. Production run, the cluster, whatever AWS clusters, the nodes would come into picture. The SQL will be running in those environments.
That is my understanding as well. But only during development, when you're using the Genie code, what is the token kind of consumption that I want to get back? So that is what I was mentioning. Yeah.
And I had seen you had put a SQL in that thing. I do not see any Python code or anything associated to that. How this would be getting converted to production pipeline?
Yeah. So basically, based on the code, right? It sometimes also creates a .py file. The Genie code, there are based on the requirement. It also can create a py file where it has a Python code. And then that is actually also part of the pipeline. So pipeline can be anything. It can be SQL, it can be Python, whatever the code you're comfortable with. And that will again be deployed to production based on the bundle concept.
The last question, how do you extract this into to push it into Git or something? Where do I see that piece of files?
Correct. So this is actually, you have to have a infrastructure connected where it will be connected to your Git, and then you can do your commits, etc. from Databricks itself.
Sure. Okay. Thank you.
No problem.
So one question in terms of what is the interest of Databricks? Are you kind of committed into that environment when you're using Genie? Is there anything there that cannot be used in a pipeline outside of Databricks?
Yeah, so outside Databricks, basically Genie is, to your question, committed to Databricks, right? It's a thing that has been done from a Databricks team who they've provided that for easy development. Yeah, so that's pretty much tied to Databricks.
Okay. So I don't know if it helped answer your side, Daniel. So they're kind of offering it free. We're hoping to let you onto the platform.
Right.
So the costs are more like they're going to cover it at the runtime, which is the bigger expense most of the time. That's my take on it. I don't know if it's
Yeah, and I'll look at it in a more detail, and I can send that information to you, Suresh, so you can forward it as well. So
Sure.
yeah, but yeah, if no other questions, that's it from my side.
A wonderful presentation, Aparna. Thank you
Thank
so
you.
much once again. We will take a short break here so that folks in the room um, can interact. And that's the whole idea about Meetup is like we meet and, we kind of understand the community as such. Daniel, you had a question or?
Yes, just a quick basic question. If I wanted to get started and redo this, where do I go? Is it databricks.com or where do I go?
I will give you the link and the document I was using for prompts. I'll send
Oh,
it to
good.
Suresh, and yeah,
That'd be great. Thank you very much.
no problem.
Yes, it is in Databricks. It is fairly well spoken about. They have a couple of webinars on it also at this point, I think. So it is kind of a conversational aspect where they actually pitching it more to the business rather than the data engineers. It's like saying that, you probably, it's the same old concept of you don't need IT anymore
Yeah,
kind of
yeah,
thing.
yeah.
The we'll do the code for you. And if you need somebody, get an expert who will review the code and, make it better. So there's a lot of that kind of documentation in terms of how to utilize that from a non-data engineer perspective. A lot of that is out there.
Right.
I don't know if it
Yep.
helps answer. In Databricks, databricks.com.
Yep. And Suresh, I'll send you all that information. So if
Sure.
anybody is interested, they can reach out to you. Okay, cool.
Okay. All right. So the next speaker here is Pratik. Pratik, if you can hear us, you can probably start your presentation. I believe it's on your laptop. So if you can start sharing that and start from there.
Yeah, hi. Am I audible? Are my slides visible?
Audible, yes, but I think the setup was better before, but that's okay. Yeah, we'll get your presentation going. Yeah.
Okay, the presentation is on, right?
Uh, Let me just make sure. Yes, it is.
It is, right? Okay. Awesome. And are you able to see me?
We saw you enough. Let's let's have you. Yeah, now we can kind of see you also.
All right.
All right, you're all set. You're on the queue. We have the slide number 1.
Cool. All right. So, hey everyone, I'm Pratik Jain. I'm a PhD student. So I'm going to shift gears here. It's a completely different topic from what we just heard. I'm going to talk about the brain. There'll be a little bit of biology. I hope you will understand all of it. And then at the end, I'll tell you how I'm using a very simple algorithm, which is the k-means clustering algorithm, to cluster the networks of the brain, and then we'll see how we can actually use them. Okay, so these are the things that I'm going to talk about, starting with the human brain. So approximately 20% of the total energy produced by the body is consumed by the brain, even when you feel you're not performing any cognitive task. So, the idea is, can we figure out what the brain is doing when we aren't doing anything? And if yes, how? So these are the things that we'll find out. Okay, so I'll have to introduce something called as resting state fMRI. What is resting state fMRI? Basically, this is an MRI machine. And inside the MRI machine, there's this participant who is asked to not think about anything in particular. So the idea is to not think about anything at all, but that's not possible. I mean, that's a thing that maybe the saints can do, maybe not us. But there's this thing that we want to image, which is called mind wandering, where the idea is, let's say you're thinking about this meeting, and then from the meeting, you start to think about the person you met somewhere, and then you think about pizza, and then you think about, tomatoes or something like that. So there's this phase of brain where, your mind wanders. And that's what we want to capture. So that's what is called as resting state. What's fMRI? fMRI means functional MRI. So functional MRI gives you a 4-dimensional representation or a 4-dimensional signal of the brain, which is nothing but the 3-dimension across time. So it's basically a brain movie that you have. Now, this thing can be represented as one 3D object or one 3D image with voxels. So you would have heard of pixels. Pixels are for 2-dimensional image. Voxels is a 3-dimensional volumetric pixel. And for every voxel, I can have a time series, which will be my 4th dimension, or which will be my time dimension. Now, what is this signal actually? Or am I looking at the brain electric signals? Am I looking at something else? What exactly does MRI measure? So going into a little bit of biology, this is a very small cartoon of the brain. Like, you have something called as a neuron, which I guess a lot of people would have known. So there's a neuron, there's a astrocyte. Astrocyte is like caretaker of the neurons. So neurons are asked just to activate or deactivate based on certain signals. And then you have these blue astrocytes, which take care of the nutrients that the neurons want, or any energy requirement or anything like that. So they just take care of the neuron, and the neuron just does the job. And then you have the blood vessel over here. The blood is what gives energy in some sense, because blood carries oxygen, and it's oxygen that is required to activate or deactivate a particular neuron, or even for energy we need oxygen. Okay, so what are we going to do here? So here, what I'm going to measure is the amount of oxygen in the blood that flows besides a particular neuron. Okay, so here I have a graph, which is basically the amount of blood oxygen in a blood vessel, basically. So initially, it'll be at a baseline level, which is 0%. And then we'll see with a stimulus. So let's say, a stimulus can be anything. So let's say this is a motor neuron, for instance, and I move my hand. So it's a motor neuron that gets activated in my brain when I move my hand. So when a particular neuron gets activated, that's the stimulus, you'll see that the blood oxygen, or the oxygen level inside the blood, will have a small dip. It'll decrease a little bit. Okay, why did this decrease? This decreased because the neuron utilized that oxygen in order to get activated. Now, the brain does a funny thing over here. So as the brain understands that there's a dip somewhere in the blood oxygen, it overcompensates it. It flushes a lot of oxygenated blood in that particular region where an initial dip was measured. So the brain, because it flushes oxygenated blood here, there's a peak that is achieved. That means there's a lot of oxygenated blood in this particular region. So what happens is, whenever there's a stimulus, you see in the blood vessels around it, this kind of a signal that comes. Now, this signal, that is the amount of blood oxygen in the blood vessels, can be detected by the MRI, because this has a magnetic signature. Oxygenated blood is diamagnetic in nature, and deoxygenated blood is paramagnetic in nature. So that's something that the MRI scanner can detect, and that's what's called as a blood oxygen level dependent signal, which I'm going to measure using fMRI. So that's what this signal is basically. So the signal is, there'll be the neurons that are firing. Based on the firing of neurons, the blood oxygen changes in the local region around it, and that's the signal that you get. Any questions about it? All good? All right. So So this is resting state data, meaning I actually don't know what the participant or the subject is thinking at that point when I'm scanning his brain. So we don't know the stimulus. We don't know when the neurons are firing. The only thing I have is this thing over here. We don't know what the subject is thinking. Also, because let's say I'll take data from multiple subjects. So I also don't know whether everybody's thinking about the same thing. Of course, they're not. They're thinking about something else. So this time series would be very different for different subjects. So in some sense, I cannot aggregate all of this data together in order to get to something, right? In order to get the truth. So what do I do? So for that, let me introduce to functional connectivity. So what is functional connectivity? Let's say I take a voxel here. What is here? Here means this is a motor cortex voxel. So we know from literature where the motor cortex is. So this, take my word for it, this is the motor cortex, okay? It is somewhere here in the brain. Now I take a voxel from there and I have the corresponding time series for that particular voxel. Now what I can do is I can correlate this time series to every other time series in the brain and get a correlation pattern. What is correlation? Correlation means if there's a time series that is similar to this time series or exactly the same, then the correlation value would be 1. If a time series is opposite to this, then the correlation value will be -1. And if it is completely different, the correlation value will be 0. So that's how the correlation pattern looks like if I take a voxel in the motor cortex and then correlate it with every other voxel in the brain. It turns out this is the motor network. So what happens is even when you're not doing any motor movement, the neurons that are the motor neurons are connected to each other if they are even a little bit activated, because even by thinking the motor neurons can get activated. So even if no explicit motor movement is being done, these things are still connected in the brain. Every red thing that you see over here are the voxels that have a similar time series or correlated time series as compared to that of the seed voxel. So by correlation, what I mean is if there's something high over here, then that other time series is also high. If it goes low over here, then it also goes low over here, and so on. Right. Then you see the yellow voxels. The yellow voxels are anti-correlated, meaning if it is high at the seed, it'll be low at the other voxel. And if it is high at the other voxel, it'll be low at the seed, and so on. And there are these other voxels which are just not correlated to that thing. So they're not in the motor network. So like this, based on a seed, so that's my seed. Based on the seed, I can get a particular network in the brain, right? Now, if I change the seed location, let's say my seed location is somewhere over here, it's this region in the brain. So if it's somewhere over there, then we get what is called as the default mode network. Default mode network, as the name suggests, is something that is default. That is, when you're not doing anything in particular, this network gets activated. It's the mind wandering thing that I just spoke about. Then, if you have it at the back of your brain, then it'll be the visual cortex. There's frontoparietal network, there's sensory motor cortex, and so on. If you notice, it's mostly in the gray matter. Now, what is gray matter? What is white matter? So if you see the brain in general, you'll see gray areas over here, and then you see a little lighter gray area, which we called white matter. So there's gray matter, which I'm just highlighting at the moment, and then there's white matter. Okay, well, what is the difference between the two? So gray matter is nothing but like bulbs, and white matter are wires that connect the bulbs. Another analogy could be gray matter are cities and white matter are highways connecting the different cities. So a lot of work has been done, to study the gray matter of the brain, but white matter is still not very well studied. There are a couple of reasons why this is the case. One such reason is signal to noise ratio. So the signal to noise ratio in white matter is very poor as compared to that in the gray matter. And now with more and more advances in MRI, we are now able to detect things in the white matter. So biologically speaking, you have, so if this is the neuron, you have the cell body of the neuron and you have the axons of the neuron. So the cell bodies are in the gray matter and the axons are in the white matter, right? Right. So what's my goal? My goal is to find out the white matter resting state networks. So I want to find out if there are networks like this in the white matter. So that's the goal. Okay, so how do I go forward? So now that's the only biological thing that I have in my slides. Everything after this is more of engineering and k-means clustering. Okay, so I take a mask because I'll have to identify which voxels are in the white matter. So let's say we come up with a white matter mask. We can do this with a lot of segmentation techniques that are out there. So I can segment out the white matter and get this mask. And what I'm doing here is I'm stacking all the voxels in the white matter mask as one 1D array. Okay. Why am I doing this will be clear in a couple of slides later, but bear with me. Okay. So it's like all the voxels in 3D look like this, but then if I stack all of them together, it's this. Good. So now what I'm showing you here is the correlation plot, the same correlation plot, but in the white matter only. So here the seed is somewhere over here. You, I guess, can or cannot see a plus sign, a small plus sign over here. So that's my seed voxel. And based on that, so meaning I take the time series from this voxel and then correlate it to every other voxel in the white matter mask, and I get this correlation pattern. The more red means the higher correlation, the more blue means lesser or negative correlation. So you can see a pattern emerges where this part is correlated, this part is correlated, this is a little bit correlated, and so on. Over here, what I'm plotting is the same correlation pattern, but stacked as a 1D array again. So this is a 1D array of correlation patterns, and this is a 1D array of all the voxels in the white matter, basically. So practically speaking, both of these are of the same size, but they just denote two different things. Right. Now, I can show you an animation where basically I am changing the seed voxel only a little bit, and I'm showing you that, I'm showing you that the networks don't change much, right? So if I go in a spatially contiguous locality, the networks are more or less similar. You can also look at the 1D array and you can see that the 1D array looks so similar. If I just change the voxel a little bit, right? Now, if I go to a different location, now I'm at a different location over here or over here, which is in the middle of the brain, then you see the pattern changes. Now, this is a very different pattern as compared to that one. But again, if I just move into that locality, then the pattern is more or less similar. So that's what we want to cluster. We want to see which voxels have the similar correlation pattern and which have different correlation patterns. So those are my networks, basically, my networks in the white matter. So how can I do it? So now I showed you this 1D array. Let me just rearrange these things a little bit. And now I can do this basically for every voxel in the white matter mask. So that gives me this particular correlation matrix, right? So now this is every voxel in the white matter and its corresponding correlation pattern. And white matter is basically the number of voxels in the white matter mask. Okay, so now I have a correlation matrix. I can just give this to the k-means clustering algorithm and get the clusters. But practically not everything is very easy because there are about 40,000 voxels in the white matter. I mean, this depends on a lot of things, but on an average, maybe it's about 40,000. So if there are 40,000 voxels in the brain, in the white matter, then I will have this 40,000 cross 40,000 matrix, which is really, really huge. A 16 GB RAM computer won't be able to handle this kind of stuff. So I mean, so I've created this toolbox for somebody who can, do it even on your local PC, right? So what to do? So because this is very high dimension, what we do is we can just pick up alternate voxels. We don't actually need, there's a lot of redundancy in this particular matrix. So let's just pick up alternate voxels. So I'm just showing you here, but in reality, we do it on the brain. So we'll pick up spatially contiguous, spatially different alternate voxels in the brain. I'll just show it to you here. So this is how the normal plot looks like if I have every voxel correlated to every other voxel in the white matter mask. But if I pick up alternate voxels, this is how it looks like. I'm not taking every voxel, but every alternate voxel in 3D. So that's what it looks like. Now, if you again look at this 1D array down, you see the pattern does not change much. Again, because similar voxels or voxels that are close to each other are mostly similar to each other. So even by this particular data reduction step, I'm still able to preserve the pattern pretty much. Okay, but because the white matter signals that as I told you, does not have much SNR, which is signal to noise ratio, what we have to do is we have to take data from, let's say, subject 1 or participant 1. So I have this matrix from subject 1, I have that matrix from subject 2, and I can have like n different participants. And the idea is that the network shouldn't change much across participants. So I can just take an average, which helps me increase the signal to noise ratio. Okay, now that's the matrix that I can just give to the k-means clustering algorithm. So what am I actually doing is I have about 40,000 data points in around about 10,000 dimension space. So the k-means clustering will work on a 10,000 dimension space to cluster these 40,000 voxels in the brain or in the white matter. So basically labeling every voxel into one particular cluster. On the brain, it will look something like this. So this is my white matter mask. And after k-means clustering, every particular white matter voxel will be labeled into one of the networks. Okay, now one question every ML engineer might ask is, how to optimize the hyperparameters or, the parameters in this case. So in this case, it's the K value, right? How do I know how many networks are there in the brain? So there's a good trick for the brain data that I can do. So I can just divide the feature matrix or my 10,000 voxels into, let's say, 4 parts. This is like a cross validation thing. So I just divide it into 4 parts. How does it affect the brain? So this was my subsampled correlation or reduced dimension correlation pattern. Now, if I further divide it into 4 parts, you'll see there are more spaces between the voxels. But again, you can see that the pattern is more or less similar, right? So the idea is to now independently do k-means clustering on all these 4 subparts. And we want a solution where the network shouldn't change just by small changes in the location, right? So we want a solution where no matter which part I take, the network should be more or less similar. So a good K value will have similar clusters no matter which part I take. So I independently run the k-means clustering over all these 4 parts and get 4 different cluster solutions. Then there's a mathematical concept called dice coefficient, using which I can compare two different cluster solutions and then find out how similar these solutions are. Now, the only thing I have to do is calculate an average across the 4 different folds. And the blue graph that you see is the average dice coefficient over different values in K. And then K-means clustering itself has a method called elbow method, by which we can find out the optimal K value. So I want a clustering solution for which the elbow method or the distortion values that I'm computing are less and the dice coefficient is high. So now based on the application I want to use this for, I can either choose a K of, let's say, 9, or I can choose a K of, let's say, 12 or something like that. So basically these peaks are my optimal K values that I have. Cool. So now I know how to cluster the brain. I know what K values to choose, but what do I do with these clusters? What kind of applications do these can these serve? So once I have these networks, so let's say I have again subject one's data. So I can calculate the average time series from every white matter functional network or white matter cluster that I have. So this blue region will have one average time series. This light blue would have another, and so on. And then I can go ahead to create a functional connectivity matrix. Now, this might be a little different for different subjects, because now I am correlating different networks in the brain. So this is like correlating the motor network with the visual network, the motor network with the default mode network, and so on. So this is inter-network correlation. So this might be a little different on the brain. And because this is a correlation matrix, so it's symmetric. So the lower half, or the values below the diagonal, are exactly the same as that of the upper half. And so I can just, take one of the halves and then again stack them to get one vector. Now, this can be the representation of my fMRI scan. There are studies that have used to identify a particular subject just by using this. So this can be used as a fingerprint. This can be used as, a age prediction thing, or this can be used to predict behavior, IQ scores, something like that. Or you can use it to predict or, diagnose or classify patients. So let's say I have all these vectors for schizophrenic subjects, and I have all these vectors for healthy subjects. Now I can, train a machine learning model. This is a very basic machine learning model that I had. Details are in this paper. Uh, that can be used to, differentiate between the two. Now, because so mental disorders are quite subjectively diagnosed. It depends on, the doctor who is doing the diagnosis. It's like a big questionnaire where the subject has to, tick mark things, and then based of that, these things are diagnosed. So imaging can give you an objective diagnosis for the same. Again, it's still not there. Putting fMRI in clinic will take, I guess, 5 to 10 years more. But that's one path to go about it. And then the more useful thing is maybe help understanding treatment efficacy. What does treatment efficacy mean? It means, let's say a subject is diagnosed as schizophrenic, and there's some medication that is going on for that particular subject. So this method can help find out is that medication is actually working, or the medication should be changed. So those kinds of things. So there are these different studies that have shown, differences in the white matter for, let's say, Alzheimer's classification or schizophrenia classification, autism spectrum disorder classification, and, these are the different things that are done. Now, that is my paper. So this is a toolbox that I've created to do whatever I just explained. And it's like a product out there. It's an open source toolbox called Wi-Fun. Wi-Fun means white matter functional networks in the brain. And that's the GUI of the toolbox. It takes care of the setting up the data, checking the data, pre-processing the data. Pre-processing is the most important and the most difficult thing, I feel. And then you can construct the networks using this particular module. Yeah, that's how these networks look like in the brain. So that's something called as a glass brain view. And there's the statistics module as well, because white matter has a lot of, the signal to noise ratio is less. So training complex machine learning models is still not there yet. It's more of simple models that can give me something that is interpretable. So for instance, over here, I'm showing you a particular functional connectivity matrix for which these two regions, this is called as the posterior corona radiata and the body of the corpus callosum, which is different between males and females. So females have the connection between these two regions higher as compared to that of males, statistically speaking. So yeah, so these are the things that the toolbox can do. And it also gives, so it's mostly for academic purposes. So when we write a paper, we need these nice beautiful figures so that our papers get accepted. So it also gives you nice publication ready figures. And that's my lab. Dr. Bharat Biswal is my advisor. And by the way, he's the person who invented resting state fMRI. So I like to call him as the Shah Rukh Khan of this particular field. And yeah, that's my lab. Thank you. I have the GitHub for the toolbox here. There are YouTube tutorials for the toolbox here. And that's my paper if in case you want to have a look. Thank you so much. That's all.
Before you go, Pratik, I'm not sure if there are any questions in the audience. If there's any, you know, questions that we have in the room or in the session here, anything on the chat?
Right.
Yeah, Daniel.
Right. So as for now, fMRI is still in the research phase. So you won't see fMRI mostly in the clinics, but so that's where we are heading to. We are heading to diagnose subjects. There's fingerprinting that is trying to identify a subject from the scan. Why is this useful? This is useful in the case, let's say, can these fMRI scans help you understand what is your IQ? So is there something in your brain which actually determines your IQ scores, or something like that? As for now, fMRI is basically used in surgical planning. So that's what is the current place where fMRI is used. What is surgical planning? Let's say there's a tumor detected in a brain, and you want to the surgeon wants to find a path where he can cut the brain and go to the tumor. Now, there are some regions in the brain that you definitely don't want to touch. For instance, the visual or the motor cortex, because if you cut the motor in any sense, the patient may be paralyzed, or if you cut the visual, the patient might go blind. So there are some regions that you definitely don't want to touch. So by fMRI, you can find out where these networks are, the visual network or the motor network, and then the surgeon has to plan a route that he can cut into the brain in order to get to the tumor. So that's the actual practical application of fMRI. But yeah, other than that, it's mostly research for now. Yeah.
Are the MRI machines different for getting the fMRI versus?
No, it's the same. So
whatever exists, whatever data is available can be used to.
yes, yes. So MRI is a very beautiful thing in the sense that based on the algorithm you give it, it can give you the different modalities. When we in general case talk about MRI, we usually talk about something called as a T1 weighted scan, which is an image of the brain, and it's usually used for the anatomy to find out, where anatomically your brain regions are. But fMRI is one such functional thing to do. Functional meaning a T1 scan cannot tell you where your motor region is. A functional MRI scan can tell you where the motor region is. So it's just a set of algorithms and the way it is acquired that can change. So yeah, to answer your question, any MRI scanner can give you an fMRI scan. Yep. Yep.
What's the accuracy now?
The accuracy?
Spring.
Oh, okay. So these, if you look at the dice coefficients, they are kind of good. So it's like 0.9 or greater than 0.9. That means even if you change the features a little bit, the networks are more or less similar. If you're talking about accuracy to detect a subject as schizophrenic or healthy controls, the funny part is if you have a smaller data set, it all depends on the data set. So if you have a smaller data set, let's say 50, 100 subjects, you can get a good accuracy of 90% or 95%. But there are now bigger and bigger data sets that are coming up, open source data sets. So now there is something called as the UK Biobank, which has a lot of subjects, like 10,000 subjects. And people are seeing that, these models that were good at the smaller data sets, that were giving 95%, let's say for a smaller data set, they are not holding true for the larger data sets. So schizophrenia is a very difficult disorder to actually, consider. But then there are these other disorders, let's say Alzheimer's, where Alzheimer's, the accuracy can go up to 80%. Yeah.
You're training on a set of samples.
Correct.
Right?
Yeah.
You talk about an opportunity for doctors to identify a section where they can do surgically.
Mhm.
So even there's 20% chance that.
No, that's a different thing. So fMRI is best to find out your motor area, your visual area with a very high accuracy. So if you're talking about identifying the brain networks, that's the only best thing that can do that for you. But using this for diagnosis is something we are still not there yet. Yeah. Hmm?
So we have a question from the audience here. I don't know if you can hear us. Daniel,
Yeah.
you want to go ahead?
Pratik, can you hear me?
Yes, I can.
Excellent presentation. Question for you on the crossover between functional analysis of the human brain, the human intelligence, and AIs. In other words, do we find any similarities or any stark differences between an AI and the human brain?
Wow, that's a wonderful question. So what I would like to say is initially AI started by mimicking the model of the human brain, right? If you talk about neural networks, they came from the same logic where you have a neuron, it is doing some processing and then giving that particular information to a different neuron, right? As for now, based on how complicated these AI models have become, I would still like to say it's mostly statistics and mathematics, right? As far as the brain is concerned, I would say there's a lot that we don't know about the brain, but this one thing that I know that for the brain, it's not at all a deterministic thing. It's completely different in the sense that um, a different input will give you a very different output, even if you give it at the same time, right? For a human brain. Now that may or may not be true for the AI models that are out there at the point. I mean, of course, you can argue saying these are random models and this non-deterministic models and so on. But then again, at the base of it, it's still statistics, probability, and mathematics. So yeah, so my take on it is, one, we don't know the brain that much, and two, I think still we might have to do something which is very, very complicated, which actually we are doing. I mean, maybe we are still not there yet, but we are on the path to achieve that complexity. I don't know if
Excellent.
I answered the question.
My last question is, you mentioned something about maybe using fMRI in a psychological setting,
Right.
maybe in 5 to 10 years, if I remember correctly. Do
Uh-huh.
you think we'll be able to get fMRI equipment to be so small and so cheap that it can be in every psychiatrist's office? Is that a possibility, or is that maybe more of a guess?
So there's something called low field MRI, where people are working on a very small prototype of MRIs, which are 0.5 Tesla strength. So to give you perspective, all these studies were done on a 3 Tesla MRI scanner, which is so in terms of magnetic field, it's 10,000 times more strong than the Earth's magnetic field. Okay. So a 0.5 Tesla scanner is something that people are working on, but yeah, again, it's still not there yet. So the 5 to 10 years that I told you was for the actual scanners, but yeah, you would require an MRI scanner, yeah. But I just wanted to let you know that there's this other field called low field MRI that is trying to answer the question that you just asked. Yeah.
Well, resting state.
Yeah. Yeah.
Say, with respect to detecting the efficacy of drugs or the application of medication, how is that done?
Right. So let's say I have a subject. I know that he's schizophrenic, and there are treatments by which, so let's say there are a couple of treatments that people do in order to cure this particular subject. Now, let's say we go with treatment 1, and I have a machine learning model with me to detect whether this person is schizophrenic or healthy. I make the subject do a treatment 1 and then get its fMRI scan in regular intervals of time. So we can see if at any point of time, is that particular subject moving towards healthy or not moving away from healthy or staying where it is. So that's what we call as analyzing the treatment efficacy. If maybe he's going towards healthy, we know in some sense the treatment is working. If it is not, we might change the treatment and then do the same process again. Yes. That's a good question. Again, because these are brain models, so it's very important to get a model which is interpretable. I want a model where I can tell whoever asks me, mostly doctors, that it is this region in the brain because of which my classifier is doing that particular thing. And SPM is one such classifier which is, I think, the best in terms of complexity and interpretability, because I can just look at these weights of the classifier and then map it to which regions or which features in the brain I was looking at. If I use, complicated neural network models, of course, I have these explainable AI and all these different stuffs out there, but it's still, at least for me, difficult to interpret it as compared to a simple SVM classifier. But there are also a lot of studies that are going into deep learning. The other important reason is, for this particular study, I had 200 subjects. For 200 subjects, it's impossible to train a deep learning model or something like that. Always. Questions?
Well, I'm guessing that we don't have any more questions. Pratik, thanks a lot. This was very enlightening and also a kind of reminder to us that there is still a lot of classical data science that can be used. And there are scenarios where the classical data science is probably the only option or the only way around um, trying to get more smarter or intelligent or get some analysis. So thank you so much for bringing us back to what we used to discuss maybe 10 years back or 11, whatever. We used to do this a lot more, but it's still a very valid and still a very foundational, you know, science that will continue to stay relevant for a long period of time. Anyway, that's pretty much what we have for this session. We will meet again in September, and we are looking forward to uh, a lot of presence here. I did send out via the Meetup messaging some links that were shared with me by Aparna. So I'm expecting that most of you, if not all of you, have got those emails for those who had signed up via the Meetup. If there's anyone who's missing it, feel free to email it to me or, send it over the messaging on Meetup or, you know, reach us in any way. We'll get you those links. But essentially, what Aparna was trying to convey is Databricks, and a lot of what she has gone over is also available publicly on the Databricks site. Thank you, everyone. It was wonderful, and we'll meet again next month.